So our text is, we're passing in our variable key, which, as we know, is whichever key was most recently pressed, and drawing that to the middle of the screen. So you can see it changing between a bunch of different letters. You can have Control, Space, Shift, etc. All those different keys. Okay, so as a section on key inputs, we're going to be talking some more about loops. So last session, we introduced for loops. So any loop can be a for loop or a while loop. They're good for repeating code a certain number of times and working with repetitive tasks. So if you have any line of code or lines of code that you're just repeating a bunch of different times, that can be a good sign that you should use a loop. So you don't have to go through all that repetition manually. So here's an example of how a for loop would be used. Usually we use for loops for iterating a certain number of times, for example, over every item in a list. So if we defined a list like this, we can use a for loop to print each item in that list. So if we go for item in shopping list, it'll loop for every item in this list. So first time through the loop, item is equal to eggs, then item is equal to ham, then item is equal to cheese, then item is equal to onions, and each of those print whichever item. And once we reach the end, we continue on to whatever code is after that. Okay, so that's an example for if we just wanted to iterate over one list. But what if we wanted to iterate over multiple lists with the same loop? So here's an example, kind of similar to the bar graph exercise we had last time. But in this one, we have a list of shades and a list of Y positions. And now we don't want to have two separate loops for both. So that'd be kind of redundant. But how can we go through the values in each list in the same loop? So let's take a look at this example. So what we can do is we can define a range. So range is a function that'll give you a list with however many numbers you pass into it. So for example, range 9 will give you the list of numbers ranging from 0 to 1 less than the number you give it. So we say range 9 not because it goes to the number 9, but because there are 9 values in this list. So going from 0 to 8, there are 9 different values here. So that's what range 9 means. And goes for any other number. So if you put range 5, it would go from 0 to 4. So it would be 5 different values, but ending at 4. So now that we know about that, range is useful when we want to repeat a code a set number of times. So for example, if we want to print hi 3 times, we could write something like this. So if we go for I in range 3, that means it'll loop through every item in the range that contains 3 items, which means it'll go through this inner code 3 times. Once for I equals 0, then I equals 1, then I equals 2. Still be marked for attendance? Yes, that should be fine. Okay, so we can also use ranges with loops and multiple lists. So for example, if we had multiple lists that have the same amount of items in them, we can use them to access each value from both of those lists with their index. So here's an example which is one list. We have a list of numbers, and we wanted to access each of the items in this list. We could go for I in range 3, if we know there's 3 items, and then for each item in that list, we're accessing it with its index, starting with index 0, then 1, then 2. So yeah, if I equals 0, access 5, print 5, then I equals 1, access 32, print 32. Then I equals 2, print 26. Then go on to whatever's next. Okay, so here's an example with multiple lists. So here we have list of balls, list of sizes for those balls. And if we wanted to create all of those balls on the screen, we could create a loop like this. So we go for I in range 4. That means this will loop 4 times. So here for the ellipse, we would get the first item from the list balls, which would give us the position of both of those, and then sizes would give us the width and height, or I guess the diameter of that ellipse. So these would be the variables for position, and these would be the variables for diameter for each of those. And we're just going through that 4 times. So first time we have position of 40, and then the size is going to be 12. Then we have position 100, size is going to be 33. Position 180, size is going to be 40. And then position 260, size is going to be 8. Okay, so let's move on to a quick question using loops this way. So the question is, what will the following code print? We have 2 lists here, and we have a for loop that goes for I in range 3. What will the result be? Okay, so let's go to top hat. Actually, I want to show both things here. Go. Okay, so that's not the code. What will this code print? Okay, looks like, yeah, almost everyone got their answers in. Just got a couple more seconds. Okay. Yeah, looks like that's everyone can show responses. Okay. Right, those of you who answered 9, that is the correct answer. So if we look at this code, let's back up. So what this for loop is going to do is it's going to take all of the items in each of these lists, going kind of one by one. So first, if I is going to be 0, we're getting the first item from both of these lists, and we're adding them to this variable result. Remember, plus equals here is going to be the value of result plus whatever this value is stored in result. So first time through, if I equals 0, then we're adding 1, then we're adding 0, so result is equal to 1. The next time through, we add 3 and 1, and then next time through, we add 2 and 2. So when we add all of these numbers together, the result is going to be 9. So that's an example of how that would work. And moving on, we can use the length function. Remember, we talked about getting the length of the list using len here. We can use this along with range to get the length of a list and define a range with that length to go through each value in a list. So here's an example. We define a list called exposition. Then if we want to get the length of the list, we can go len exposition. So it's going to be 4. And then we can pass that into a for loop. So go I in range n, which is 4, and it'll loop for however many values we have in that list. Okay, so back to this bar graph example. So we were talking about how we could use multiple lists within a loop. Here's how we would do that. So we can define a range of 4, since we know both of these lists have a length of 4. And then if we go for I in range 4, we can access the colors through that index, and we can access the Y position through the same index. So for each bar, we're going to get a color and a Y position, then a different color, then a Y position, color, Y position, color, Y position. Okay, so let's move on to our first exercise using these concepts. So in this exercise, we're going to create 3 circles that move to the right with 2 lists and a for loop. So we're going to need a list of X positions and a list of Y positions for each of the circles. So first, just figure out if you can create these circles and make them move to the right. And then as a bonus, for using our key pressed variables that we talked about before, you can use the WSD keys to see if you can make the circles move to the left or right when you press those keys. So yeah, some prompting questions here. What loop should you use to loop through both lists simultaneously? It's going to be pretty similar to the examples we discussed previously. And yeah, for the bonus, for making them move left to right, that would be, you need to figure out what value in each of the ellipses you need to change. So you can open up breakout rooms for this now. Okay, yeah, we got the breakout room set up. Yeah, some of you might be in different rooms than usual because we have a lot of mentors missing, but all right. Yeah, looks like we got everyone coming back. Okay. Yeah, looks like we have everyone back now. Yeah, hopefully we all got some time to try out that exercise. So you should have something like this. The main point here is having this for loop that we define for the range that is equal to the length of this list. So if we know that's 3, we can just put 3, or we can use the len function as we saw before. These will both do the same thing because the length is just 3. And so I is going to be each of the indexes from 0 to 2. And we're grabbing the index of each of these coordinates from the x list and the y list for each of these ellipses. So first time we get first element from x list, then first element from y list. So we're drawing it at 100 and 300, then 200 and 200 for the next one, then 350 and 250 for the next one. So that's how we're drawing all those ellipses. And as for moving them, we have key pressed functions for A and D that can modify a move offset, and we add that to the X position for each of the circles. Okay, so hopefully that makes sense. We're going to move on to talking about different kinds of loops. So far we've just been working with for loops, which are good for when you need to run a loop a certain number of times, and you know how many times you need to go through the loop. But while loops are good for if you don't know that, and if you just want to loop until some condition is true. So here's how a while loop works. So if we want to have a while loop that's like eating food off your plate, so if we start the loop, you're eating food off your plate. Well, there's still food on the plate, so this would be your condition. Take another spoonful. Once there is no food left, put your dishes away. So you are just going through the loop while this condition is true. So you don't know how many spoonfuls it'll take, but you just keep going until this condition is no longer true. So here's a flow chart of how this works. So let's say we want to make a simple loop that counts to 10. So we set I equal to 0 and say, well, I is not equal to 10, print I, and increment I by 1. So this loop will run as long as I is not equal to 10. So we do whatever code comes before the while loop, then we have some condition here. If the condition is true, go through the body of the while loop, and then go back to the condition. If it's true, go through the while loop, go back to the condition, and so on and so forth until the condition is false. And once the condition is false, then we exit the loop and go on to whatever's next. Okay. So with while loops, can be tricky because we can get caught in an infinite loop if you're not careful with how you're incrementing the values. So in this example, what would happen if we removed the line x plus equal to 1? So we're no longer incrementing it by 1. So what would this do now? Like how would it work? Like if we look at this, I is equal to 0, and we say, well, I is not equal to 10, print I. Then we go through again, I is still equal to 0, print I again. Then we go through again, I is still equal to 0, and so on and so forth. Forever. That's not good. We don't want our program to go on forever. So whenever we have a while loop, you got to make sure you're always incrementing your variables so you don't get caught in an infinite loop. So now we have a question on this. Which line of code do we need to add to this to avoid creating an infinite loop? So let's take a look at all of these possible lines and see which one of them would avoid looping infinitely. Should get top hat up. Okay, here we go. Next question. see how many answers we got. Sorry, yeah, I forgot to go over this. Yeah, don't test these. You should just be able to look at it and tell what it will do logically. Again, we also want to avoid running infinite loops, because in some cases that'll crash your computer, and we don't want that. Yeah, I mean, for this one, it's pretty simple. So likely what it will do is it won't crash. It'll just, if you get in an infinite loop, it'll just like print a bunch of things forever until you exit the program. But yeah. Okay, looks like we got everyone answered that. So let's look at these responses. Okay, I think most of us got it. So yeah, those of you who answered A, that is the correct answer. Because let's look at what each of these lines would do in this case. So for I equals I plus 1, first time we go through this line, I is going to be equal to 1, then I is going to be equal to 2, then 3, then 4, then 5, then 6, then 7, 8, 9, and then eventually 10. And then well I is equal to, or no, well I is not equal to 10, we run the loop. So since I is now equal to 10, this condition is false and we can exit the loop. Now for the rest of these, we're not going to reach 10 because if we have I is minus than or equal to 3, or no, that's not. So this means I is equal to I minus 3. So we go through this. So 0 minus 3, that's going to be -3, then -6, then -9, and we just keep going down. And at no point is that ever going to be equal to 10. So the loop just continues on forever. Same thing with this one. We're adding -5. So we go down to -5, -10, -15. We never reach 10. So the loop just continues forever. Same thing. All right. So as we can see, while loops are very useful for when we don't know how many times we need code to repeat. For loops will repeat as many times as you tell it to. So you need to know how many times it will repeat. You're usually repeating over a certain list or a certain range or like a certain number of times. You know how many times it needs to repeat. While loops, you might not know how many times they need to repeat. So you give it a condition and say repeat while this condition is true. All right, here's another example. So here's an example where we're drawing a certain number of ellipses. Now we don't know how many ellipses we need to draw, so we're just making it based on our mouse X position. So we're saying, well, X is greater than mouse X, or sorry, well, X is less than mouse X. We draw an ellipse at a certain X position and increment X by 20. And so we do that until X becomes greater than mouse X. And so that way the circles will not continue past wherever our mouse is. Okay, so let's look at a different exercise where we can use while loops. So in this exercise, we need to use a while loop to build this pyramid of different rectangles. So here's a hint. If you start with the variable y equals 10, you can use that to make your while loop condition. So this will be similar to the previous one where you want it to be based on your mouse's Y position. And with that, you can figure out what condition you would need to use to create these rectangles. All right, a few things to keep in mind. X is going to be the same for all these bars. Height is going to be the same for all these bars. The length is determined by your Y coordinate, and however many bars you create is also determined by the Y coordinate. So you can start breakout rooms, figure out how to combine all these things together with a while loop. Okay. Yeah, it looks like we got everyone back. So for this exercise, I think once we get the logic of how the while loop is supposed to work, it should be pretty simple. So an example we had in the slides was this, where we are drawing a certain amount of circles dependent on how big this variable x is. So for this exercise, we're doing a very similar thing, but with our y position instead of our x position. So these rectangles, the position is going to be dependent on some variable. You can call that y or rect y. I called it here. And so we're changing that position variable, and we're also changing the length. And we can do that with the same variable. Just kind of use one variable for two different things here. And the logic of this while statement is very similar to the other one. We're saying that while this variable, rect y, is less than mouse y, so our y position of the mouse, we are going to draw another rectangle, and it's going to be 30 pixels wider and 30 pixels further down the screen. And so that's going to look like this. So if it's there, we can only draw one. But as we move down the screen, rect y is going to be able to get larger since our mouse y position is larger, and we're going to be able to draw more rectangles and get more loops through that while loop. Okay, so that's how that exercise works. We have a couple slides here on break and continue. It's not really necessary that you know these, so we're kind of just going to skip over them. But if you want to read these slides on your own time, I think that there's still good things to know. We're not really going to use them in any of the exercises going forward. So we have one last thing to touch on in this session, and that's going to be how to use random numbers. So random numbers are something we can use to provide variation in our code. So to generate random numbers, RNG, if you will. So what we do is we're importing another library. So similar to processing, we are importing the random library. And that is going to give us access to functions that create random numbers. So one of those is random.random. That'll just give us a random decimal between 0 and 1. So that can be kind of useful, but the most useful one we're going to be looking at is going to be randint. So that's going to give us a random integer between A and B. So within the range that you provide, it will give you a random integer. So if you pass in 0 and 3, it'll give you a random number between 0 and 3, including 0 and 3. So that can either be 0, 1, 2, or 3, just randomly. And example of how that could be used, let's say we want our diameter of these circles to be selected randomly from the range of 25 to 75. So we could find diameter with randint, as we see here, and that'll give us a bunch of random diameters for differently sized circles. Okay, so a couple of our end of session exercises will use these. But most importantly, it's important to be able to use lists for these. So a lot of these, we're creating a bunch of different elements on the screen, and to be able to keep track of each of these elements, their position and size, we want to be able to define lists and add variables to those lists so that we can keep track of where they are on the screen or how large they are in this case. So yeah, here we're just using the mouse button to add circles, and then those circles are moving up the screen. Think of how you would put all of those positions of all of those circles within lists. And here, for creating circles that expand over time, the positions of all the circles are going to stay the same. But we want to also have a list to keep track of the size of the circles. So keep that in mind too. And so here's the ones for Pythonic Lava. This one, we need to be able to use the random library for this one. So this is using the mouse button to add circles with random speeds. So as you can see here, each of the circles are going to have a different speed, both in the X and Y direction. So you can think about how you would define that. And this one is just, yeah, using the mouse button to add circles, and they go back and forth on the screen. We have a few just for fun ones as well, if you have time to get to these. These are using a bit more randomness. I'll let you just take a look at those, maybe try them on your own time. And lastly, here are the submission links. If you do not have them already, they're on the slides and they work. So yeah, those are all the exercises. We'll have the rest of the session in breakout rooms to work on those exercises.